Hi everyone, it's Alyssa and welcome to You Can Learn Math. Today we're talking about the greatest common factor. Greatest common factor is when I have something like, say, 5x plus 10, and I want to know what is the biggest number that goes into both of them, that will divide cleanly into both of them. I don't mean just to divide into them because, well, technically I could divide anything into them. I could divide 5,728,692 into both of them if I wanted to. Why? I don't know, but I could. But that's not what we want. We want something that divides cleanly into them. So if I put, 723 under here, am I going to get a nice, even whole number or integer? Nope. But what if I divided this by 5? Yes, that would work. That's what we're talking about. So when we're looking for the greatest common factor of two different terms, there's two major things we're looking at. First, we're looking at the numbers, the whole numbers, the integers in each term. Okay, occasionally sometimes they're fractions and decimals, but you know what I mean, the numbers in each term. Then we're talking about the real numbers, and then we're talking about the variables in each term. In this case, only one of them has a variable. That's not always the case. So first we look at the whole numbers. We say, I keep saying whole numbers, and you are going to have fractions and things, so I should stop saying that. We'll just say numbers, the real numbers. First we look at the numbers. The numbers here, 5 and 10. What's the biggest number that divides evenly into both 5 and 10? Well, that's 5. 5 divided by 5, if I divide by 5, it leaves 1. And if I divide 10 by 5, it leaves 2. Boop, boop. Then I have x. Do I have a variable in both of them? No, I don't. So there's nothing I can do. So the x just comes down. And that's it. That is the greatest common factor. And we can test to see if I did it correctly, because if I multiply back, 5 times 1x equals 5x. And 5 times 2 equals 10. Yep, that gets me back to the original. Also, I want to look at what's here in my parentheses and say, is there anything else that I can pull out of this? No, there isn't. Now, something like this, 5 and 10, it's pretty straightforward to see that 5 goes into both of those things. Well, what about when we get something that's really a really huge number? How do we know what the factors are? And when I say really huge, I mean beyond the scope of the times tables. So you don't have in your head right off the bat, say something like 453. What goes into that? And you can go, I don't know. I don't know what goes into that if you're comparing that and another number. One thing you can always do with these is actually do a factor tree. If you've seen that before, if not, here goes. You start with any number you can think of that goes into this. If it's an even number, right off the bat, 2. Easy peasy. This one, another little trick, if you add the digits of a number up, any number known to man, and they equal something that's divisible by 3, the number is divisible by 3. So 4 plus 5 is 9, 9 plus 3 is 12, 12 is divisible by 3. Yes, this is divisible by 3. And see, look, it keeps on working. Because here you have 1 and 2, 1 plus 2 is 3. Divisible by 3. All right, so this is divisible by 3. 3 goes into that, let's see, was that 151 times? Okay, and 151... let's see, it's 151 prime. I have to check on that real quick. I just picked 453 out of mid-air, and I may have got one. Yes, it is. 151 is prime. Well, that was easy enough. Totally did not plan that. Okay. Okay, so anyway, normally, let's try something like a little bit smaller, but I know is going to have a lot of factors. 144. Okay, so 144. If you didn't know that this is 12 times 12, you would see it was even. It could start with 2. It really doesn't matter. Or you could do 1 plus 4 is 9. So I know this is divisible by 3 because the 3 integers here added together, 1, 4, and 4, add up to a number divisible by 9. You know. Anyway, but because I know it's divisible by 12, I'm going to start with that. 12 and 12. I know 12 is 3 times 4. 3 times 4. And 4 is 2 times 2. 2 times 2. And if you had been at this point, the 12, and instead done 2 times 6, you still would have gotten the same thing. Because it's all of the things at the bottom of the tree. We got 3, 2, and 2. 3, 2, and 2. And look over here, there's 3, 2, and 2. So you get to the same answer regardless. It's fine. So 144 is the same as 2 times 2 times 2 times 2 times 3 times 3. That is its factorization. You're trying to get so that it's all prime numbers. You're getting down to the prime numbers that you can't factor anymore. And then you've factored it completely. So you may be asking yourself, like, okay, Alyssa, that's fine, I guess, but why should I care about this and what does this have to do? Well, here you go. What if I had something like 72 and I've got, let's change that. Let's say 60. I have 60 and I have 144 and I'm not great at my times tables and I don't know what the greatest common factor here is among these two. So 60, I go, okay, I factored 144. Let me factor 60. 60, all right, it's 10 times 6. I know that because that ends in 0. Okay. 6 is 2 times 3. Both of those are prime. 10 is 2 times 5. Both of those are prime. To know the greatest common factor of these two numbers, I look at what they have in common. So I'm going to use rainbow here. I have a 2 and a 2. Another 2 and another 2. Another 3 and another 3. Any other numbers that match up? Nope. So my greatest common factor of 60 and 144 is 2 times 2 times 3. The three numbers they share, or 12. So that's where this comes in. If you are dealing with smaller numbers and you're trying to find the greatest common factor, it's usually pretty straightforward. You know, if you know your times tables pretty well, you'll be able to figure it out pretty quickly. But as it gets a little bit bigger, or if you're a little rusty on them, this is how you can break the numbers down and find the greatest common factor. Okay, so let's put this into play, as it were. Let's say I have, actually we haven't done a variable yet, so let's throw some variables in there. 49x squared plus 35x. I need to know the greatest common factor and pull it out like a reverse distributive. I'm undistributing it, as it were. So I'm going to look at the numbers and then the variables separately. So first I look at 49 and 35. I go, what numbers go into both of those? Those are both, I'm pretty sure those are both in the 7s times tables. So I'm going to see if I take 7 out, 7 times 7 is 49, and 7 times 5 is 35. Okay, now I have x squared and x. What goes into both of those? X. And here's why. I can say x squared divided by x equals x, and x divided by x equals 1. So I can divide both of those by x. So that's what I'm going to do. I'm going to pull that x out and divide both of them, which leaves x and just a 1, which I don't have to write. So 7x times 7x plus 5. And if you redistribute those, you will get that original answer. So this is what's actually happening over here. You're dividing each term by 7x. It's a x squared divided by x and x divided by x. That's what's happening. So you'll see the pattern where you can do like a little jump ahead with the variables. This can be any variable. For example, let's see. Okay, here it can be multiple variables. So in this one, what goes into both 12 and 3? What's the biggest number that goes into both of them? 3. And what's left in the parentheses? 12 divided by 3 is 4. 3 divided by 3 is 1. I know in the end we won't really have to have the 1, but let's just put it there for now so we know that it's there. All right, now we have our x cubed and our y. So for the x cubed, and our x, we have our x cubed and x. What's the biggest number, or variable in this case, that they both can be divided by? Well, that is x. X cubed divided by x is x squared. X divided by x is 1. So I can divide them both by x, and that leaves an x squared, and again, a 1. All right, now for y. I have a y, and I have a y squared. What's the biggest variable they both can be divided by? Y. Y squared divided by y equals y. Y divided by y equals 1. So here, this first one, y divided by y equals 1. And this last one, y squared divided by y equals y. So I'm going to write this together, and I'm going to get rid of those ones because, you know, they're there, but we don't really have to write them. And there we go. And if I multiply back, oh, silly me. There we go. If I multiply back, I put the little y there too, then I will get that number there at the top, 12x cubed y plus 3xy squared. So you just have to be very careful and it's like what I just did. It's very easy. This isn't proof in action. It's very easy as you're dividing these to forget to write something on the outside or to forget to write something on the inside. Just be very careful when you're dividing, because this isn't as difficult as some of the other things you do in factoring. It's, you know, for most people it isn't, I should say. But for some of the other things, I will say some of the other things in factoring are more difficult than this. So especially, you know, some students find this very simple once they get the hang of it, and they're like, oh, and they start breezing through it. It's very easy, like I just did. It's very easy to kind of be going through it and forget to write something down on the outside or inside. So just want to be very careful with that. Okay, so here's a couple of examples here. I'm going to go through these a little more quickly. So let's say I have, let's see, 34 x cubed y squared minus, I don't know, 2xy to the 5th. Okay, what can I take out of both of those? If I look at my numbers first, I can take out a 2, leaving 17 and 1. For my x's, I can take out an x, leaving x squared and just 1 over here. And then out of my y squared and y to the 5th, I can take out a y squared, leaving just 1, and leaving y cubed over here. So to write that, 2xy squared times 17x squared minus y cubed. Okay? And as you may have noticed, every time we're saying what's the biggest thing we can divide out of these two, when they're talking about the variables, it is the same as the smaller one. So, for example, up here, I had x cubed and x. What did I pull out? X. I have y squared and y to the 5th. What did I pull out? Y squared. It's just the smaller of the two. So that's a nice little shortcut But the actual math that's happening is we're saying y to the 5th divided by y squared is y cubed, so that's what's left, and y squared divided by y squared is 1, so that's what's left. Okay. One last little example. Let's see. Wait a second. Nah. I don't want to do that. All right, we'll say 99 w cubed z squared plus 55 w x y z. Okay. For this one, I would say, all right, for both of these, 11 is the largest number that goes into both of those numbers. It goes into 99 9 times. It goes into 55 5 times. For our variables, I have a w in each one. I pull out the most that I can, which is just w, and it leaves w squared in the first one and just the number 1 in the second, so I'm not going to write that. All right. Then going in order in the alphabet, is there an X in both of them? No, only in one, so I can't pull anything out. It stays. Next is Y. Is there a Y in both of them? No, so I can't pull anything out. The Y stays. Now, my Z's, Z squared and Z. It's in both. What's the biggest I can pull out? The smaller of the two of them, Z. So I can pull out a Z, and that leaves one Z in the first term and no Z's in the second, and it is a plus. And if I multiply back, I will get what's on the top there. All right, so that is finding the greatest common factor and pulling it out, like as I call it, like undistributing. And this will come in handy when you start doing factoring very shortly. So again, always remember, keep your numbers and your variables separate when you're doing this. Take them separately, treat them separately, and just be very careful. And especially as you get the hang of it, this will probably become something you can do very quickly. So just make sure not to go too fast and make a mistake that you'll just kick yourself for later. You're like, I knew how to do this. So anyway, that's going to be it for today. If you enjoyed this, if you like or was helpful in any way, I know some of you probably didn't enjoy it because math may not be your favorite thing. I'm sorry. I hope it gets better. I hope you learn to like it more over time, or grow to like it more, I should say. In any event, yeah, where was I? I was thanking you for stopping by, and I was saying if you'd like to watch more of these, if you found it helpful, please like, share, and subscribe. It really helps. And please, if you have more questions with algebra and stuff, you can leave them in the comments below, or look through many of our other videos that are there on algebra, geometry, etc. So thanks for watching. Have a great day. Bye-bye.